So for today, this would be I don't know, if you were a little bit lost last week in terms of like what the vertex is and x-intercepts and things, this is just going to define all that stuff for you. So it's good timing. Okay. But hopefully, maybe even by the end of the day today, we're going to discuss vertex form a little bit more in depth. You could probably go into the review that I gave you and answer the few questions that I told you not to do because they dealt with vertex form. Okay. There's no change to the procedure. It's just a different looking equation. Okay, it does the same thing though. Same parabola. Okay, so the vertex, so all we're going to do today is just, well, we're going to do two things. We want to be able to distinguish a quadratic versus a line too. Remember, we would have done this lesson coming out of all the linear stuff. So this would have fit better, right? But you can prove a quadratic is a quadratic versus a line using some of the stuff that we're going to do today, okay? And I'm going to ask you that on the exam and this Unit 4 test, obviously, okay? So we're just going to run through some of this stuff. We're going to use some proper language around parabolas, okay? And then get a little bit more experience. This will help you with the key features. So when we start talking about axis of symmetry and the x-intercepts and the vertex and direction of opening, like those questions on the backboard that Mr. Lin did with you guys. Okay? Hopefully by the end of the day today, you have a little bit more context around what those things are. Okay? And it'll help you for the test on Wednesday. Okay? When I ask you one of those questions. Okay? So, the vertex is a point on the graph with the least or greatest y-coordinate, okay? So for instance, you got two little like Cartesian grids here, okay? The vertex, when it opens up, you're gonna have a minimum down here. So well, it's what you guys already know it as a minimum, but minimums go with least, okay? Then the only other option you have is if it opens down, right? This is going to be a max. And it goes with the greatest y-coordinate. Okay? Does anybody still struggle with... I never said this last week, but does anybody still struggle with... the direction of opening piece? Frowns go down. Does that help? I don't know. I never mentioned that. This looks like a frown. Frowns go down. There you go. You won't mess it up now, hopefully. It's Monday, sorry. The jokes get better as the week goes on, right? I think we left off with a pretty good joke on Friday, I think. That's right. That was a good one. I thought it was funny. I laughed about it all weekend. It's good. I don't know. Just a little bit older than you. Okay. Direction of parabola opens up. Okay, can easily seen by looking at the graph, okay? It can also be found by investigating what we're going to call the second differences in a table. Okay? So it opens up if the second differences are the same. You're just writing this down now. We haven't really provided too much context with this. Okay, we'll do it on the back side of this page. Or a positive sign. Okay, we'll see that on the back. Just gonna see. I'll show you how to do that. You guys did it with lines in grade 9, or you should have. Okay, that's the way you proved that a line was a line. Was a first and second. Well, first differences you checked, right? We're gonna do that with the back. Okay, the optimal value we've discussed already too. It's kind of nice, right? The optimal value can either be a maximum or a minimum depending on the direction of opening, right? So those are the two blanks there. Be a max. You could just write max or min too. Depending on the direction of opening. Okay, so a maximum occurs when the quadratic opens what direction? What do we draw up top? Down. Maximums occur when the parabola opens down, right? It's like when I throw a ball, the ball goes up and comes down when the ball reaches the maximum height, right? Okay, so it's down. Okay, an example could be like, we'll draw one over here on the side. Can everybody see how this is kind of like related to what we did last week? It's kind of helping you with the table that I gave you, or the questions on the backboard. If this is like, let's say, I don't know, 1 and 5, the vertex, then we get a maximum of 5 when x equals 1. Can everybody see that? See where those two numbers came from? That's how I'd like you to write. Like when I write it in the table like that, where we've got max / min at whatever, I want you guys to like circle max or min and then tell me what the value is when x equals whatever, right? So some of them are like, one of them looks like -3 when x equals -1 sort of thing, right? Kind of lock it down. You're just reading the vertex. You're putting words around the vertex, basically, is what's happening. Okay. Any questions? And then therefore, like, the minimum must occur when the parabola opens up, right? So we could draw another one here. We could do 2, 3 for this one. 2, -3, sorry. So you're going to get, this should say minimum. Minimum equals -3 when x equals 2. Is that okay? Okay, and the next one, we've discussed all these, but this is kind of nice because we're putting it all down. Zeros, also known as roots, solutions.
You end up figuring out what the fourth thing was?
Yeah, zeros, roots, solutions, x-intercepts.
Were we committing 0?
Something, yeah, I can't remember what it was. Those are the 4. They're interchangeable. You'll see questions that say solve for the roots, solve for the x-intercepts, solve for the solutions. They all mean the same thing. You're going to do the exact same thing. You're either going to use the square root method, you're going to factor, or you're going to use a quadratic equation. Right? It's going to spit out the x values that satisfy the equation. Okay? They all mean the same thing. Okay? The zeros, okay, this is just providing context again, is where it cuts through the x-axis. Right? Which one's the x-axis? The horizontal. Okay? The next one, the axis of symmetry, okay? What did we say the axis of symmetry was? We know it's the halfway point, right? But it's actually physically a vertical line, right? So we need to, like, anytime we wrote the equation of a line, we always wrote it in y equals mx plus b, right? Does a vertical line have any slope? Does it ever, so I guess this is just a side note. This is just me thinking off the top of my head because we've done all this stuff. A vertical line is the blank, okay? If I drew a vertical line, like if I drew this axis of symmetry right here, how would I write, that's not straight, but you guys get the idea. How would I write that equation? I suppose, does that line have any slope? Is my question. We can shake our heads no, but I kind of want to like dive into why it doesn't have any slope. But what is slope? M equals rise over run. Does it rise? It rises. That's fair, right? It goes up and down. So we're going to have a number. It doesn't matter what it is. It's a number in the top. Does it ever go horizontally, though? It's horizontal, right? So what ends up happening is we divide by 0. What happens if you type that in your calculator? Can you divide by 0? What ends up happening on your screen?
Error.
You get an error. It's not allowed. So, if you recall, y equals mx plus b, where was the slope? It was m. So what does this make it? This whole piece is 0 because it doesn't even exist. Y equals b is how would you write? That's kind of how you would, in theory, write the equation. But what's the issue with it? Is it taking on a bunch of different y values or one y value? So if I said for this particular question, if I said y equals -2, is that the equation of the line? Like if I graph the line y equals -2, where would that be? It would be here. Right? Is that a vertical line or horizontal line? How did we write the axis of symmetry on Friday? How did we write it on the sheet? I just told you to write it that way. I didn't tell you why. X equals -2. Okay? Y equals -2 is a horizontal line. It's a bit counterintuitive because you normally associate y with being vertical. But if you look at this black line, every y value along here is what? -2. The opposite's true for vertical lines. Every x value along here has a value of what? What's the x value along the red line? So that's why we write x equals -2.
So is it like y is for like slope of 0 and x is for undefined?
Yes. X is undefined for vertical lines, right? And the slope is 0 for horizontal lines. That's because if we go back to our little discussion here around slope, if I type in the slope for a horizontal line this time, like let's say the black line, what happens? Rise over run. Is there any rise for a horizontal line, the black line? No, so it's 0. But is there a run? So it's a number. What are you going to get then? 0. That's allowed. Okay? That's why it takes on y equals b for a horizontal line. But the vertical line is the same thing, except it actually doesn't even have, like, its slope is undefined. You can't write it as 0. Okay? So that's just a side, like, tangent. You'll need that. You guys take grade 11? There's a whole unit based off of, like, not being allowed to divide by a number, divide by 0. There's a whole unit based on that, and you produce graphs based off of that fundamental principle. Not being allowed to divide by 0. That's a whole unit. You produce graphs. Okay? And you take your factoring skills and you apply it in that unit, which is why we spend so much time factoring. Okay? And it's always written as an equation, okay? So x equals -2 is the equation. Okay? So let's try some examples. Okay, turn the page over once you got that. This is the sort of thing I'm going to ask you on the exam, okay, with an extension. We're going to ask this and more on the exam, okay? It's not hard. In grade 9, you guys would have done just this. Okay. We're just going to take it one step further now. Okay. So here's what we need to do. We need to come up with the y values that correspond with the x values. Okay. So I'm going to say here's a point here. There's a point. There's a point. There's a point. What are the y values for each of these? Can anybody just read them off? -4 and what? 6. Sorry. No, the y value is +6. Okay. And then -3, 0. -2, what? Okay. And then 1, 0, and 0, 6. Now, does anybody notice anything interesting here? If you didn't understand axis of symmetry before, maybe you'll understand it right now. Let's just look at strictly the values of the in the table there. If I drew a horizontal line here, you don't have to do this. I'm just doing this to show you. What do you notice about the numbers specifically on either side of that red line, top and bottom? They're opposites. Not opposites. They're the same. Specifically the y values. So if you had a table of values, you could identify this as being the axis of symmetry, right? Because if we look at, there's a 6, there's a 6, there's a 0, and there's a 0, where would be my axis of symmetry here? If I didn't have the graph, like pretend I didn't have the graph. You could tell me where the axis of symmetry is. It's right here in the middle. -2 splits everything in half, right? I can confirm that by looking at my graph. There's the axis of symmetry right there. So we know it's at x equals -2, right? Yes?
Wouldn't it be the x like that, the row of like x that gives you your axis of symmetry, not the y? Axis is like the axis, right? Not y. Y doesn't really tell you anything. It's more x.
Yeah, we're gonna come to learn that the y value, it's a combination of both, right? Because let's say I only gave you half of the parabola. Could you do the other half? You could, right? Because I know where I know that this y value right here is 1 unit away from the axis of symmetry, so it must be 1 unit away on the right side as well. Right? And then I'm like, okay, well, here's another one up here. It's 1, 2 units away, so it must be 1, 2 units away on the top too. If I give you half the parabola, you can produce the other half. Okay. Okay. What about the optimal value? Or we could do the vertex first. Where's the vertex? Right here. Okay, and then I have an optimal value. Is it a maximum or a minimum? It's a minimum because it opens up. It's a minimum at -2 when x equals -2. Where's the y-intercept? Does the y-intercept change relative to lines? Y-intercept is always the y-intercept. It doesn't matter what graph you're working with. It's wherever it crosses the y-axis. Where's this graph cross the y-axis? Right here, right? 0, 6. Okay? Now, here's the part you guys would have done in grade 9. Here's what we got. Got these things called first differences. Okay? This is like a test. This would have been a test to see if something was linear or not, like a line. Right? And what you did is you always checked, you always did the subtraction. You can always go 6 minus 0 should be 6. Right? So it's differences. Is everybody following? You always take in one number and subtracting the next one. And then you do it again. 0 minus negative 2. Here, maybe I'll write it in here. So I just won't write numbers. 6 minus 0 equals 6. 0 minus negative 2 is equal to 2. Negative 2 minus 0 equals negative 2. And 0 minus 6 equals negative 6. Now, if this was a line, and I'll ask you this, when we do the actual like kind of applications of quadratics versus lines, like come up with an equation sort of thing, called modeling, you're going to have to tell me if it's linear or quadratic. This is how you would tell. If these were all the same number, which we'll see in a minute, then it would be linear. If it's not all the same, you don't know what it is, you have to do a second difference test. Okay? You're literally doing the same thing again, except with those numbers in red. I'll leave them highlighted. Okay, so let's do it again. Except this time we're going into these boxes. Okay? 6 minus 2 should equal 4. 2 minus negative 2 should equal 4. And negative 2 minus negative 6 is equal to 4. What does this tell us? Those numbers are all the same. If the second differences are all the same, then it's a quadratic. If the first differences are all the same, then it's a line. And you don't have to go any further. Does that make sense? Yes, Coco?
So when you do the second differences, they're all the same number?
If it's a quadratic, yes.
What if they're not the same?
Then it's not a quadratic.
What would it be? Cubic?
If you keep going and going, yeah. If you had x to the power of 4, you'd have to check the fourth differences. X cubed, you check the third differences. We're not going to do that, but it's a tedious exercise, right? When you get to that stage of math, you can see it from the graph what it is, I guess. Okay? Any questions? You guys want to try a second one? That's it. You guys try a second one. See if you can fill it. You've got an example there. I'll take it up in a minute. Okay? Get started. I'll give you a couple minutes. See if you can fill in all of the information. You've had a head start on this because we did some of this last week.
It's kind of hard to read.
Yeah, it's really hard to read.
Oh, okay. It looks like.
The y-axis all looks like -4.
Yeah, I think what it's doing, that's true. It might be 1, 3, 5. Let's just go with that. -1, -3. I don't know why you would do that, but that's what it is.
And for what about for the x-axis? Are we just going with 1?
Yeah, let's go with 1s on the x. I think that's what it is. That's my bad. I didn't look at that.
Can you choose to go by one on the y-axis instead like it is here?
Do you guys want to go by 1s on the y-axis? I don't care. Whatever. This is like we're just making this up, really. Doesn't matter. It's not like we're coming up with the equation or anything. We're just proving whether or not something's quadratic. Okay, give it a go, see what happens. Hopefully it works. It should work.
It's asking, like, what is the y value when x is -4? Where, like, what -4 is it? Right here, and there's like,
Nothing.
there's not.
It might not be a great graph, but it would be something. It'd be really, really far in the negatives, right? This one's like, I'll show you what the deal I think with this question is in a sec. What do you notice as an issue with this question? There's a couple issues, okay? It's not that it's like there's nothing wrong with the parabola. It's just not a nice one. So why is it not a nice one? Retta or Sarah, doesn't matter. Sarah.
The x-intercepts aren't on a whole number.
Yeah, okay, so these aren't great. These aren't great. The x-intercepts here, we'll do it in different colors so you guys see. X-intercepts aren't great. What does that kind of imply?
Decimal.
Which implies what? Here, let me write this in sequence as you guys write it. Say it out loud. This is what's going on in your head. When you look at something like that, like we're thinking, this is the sequence of thoughts. It's a decimal of some kind. What does that mean? Probably not factorable. Not probably. It is not factorable if you have decimals. What else could you tell me about that? What are you going to do? What is that? What does not factorable mean? What chances like the likelihood of you using something?
Like, I mean, you have to use quadratic formula.
Yeah, right? So chances are or what was the other issue? Not issue. What was the other one I showed you? These are the thoughts that are going on in your head when you see things like this. If they're not nice parabolas, you know, you're thinking, okay, if the quadratic equation's been used or if solved with square rooting, it's not a factorable one, right? You could take a guess at what the roots are. You could figure it out for sure. It's just a lot of work. Okay, I'll show you how to figure it out. Okay. What was another issue?
I mean, I was gonna say the same one.
Well, you guys brought another one to my attention too. Right? It asks you for a y value for x equals -4. Where's that going to be? Down here somewhere. Not useful, right? What about -3? Again, same thing. -2's getting a bit closer though. Still not useful though. Right? So if you were to plot this, like you wouldn't pick those points as being points of interest, is I think maybe the point here. You're going to want to pick points of interest that are kind of around what? Points of interest being x values around what? The vertex. What's the vertex in this question? You could fill out some of the stuff.
3, 3, 2.
2, 3, you mean?
Oh yeah, my bad.
So the vertex you could write as 2, 3. You can fill out the fact, you can see it's visually opening down. So you can say there's a maximum. There's a maximum at 3 when x equals -2. So the axis of symmetry is going to be x equals -2.
Wait, 2.
Oh, sorry, you're right. Sorry. Look, we're 1 for 1. You've made a mistake. I made a mistake. Okay, yes. I might still be losing that one, though. Direction of openings down. What's the y-intercept? Yeah. 0, -5. So you can fill out a whole bunch of stuff here. If I really wanted to ask you this question to figure out, to tell me what the x-intercepts are, what could you guys do? I could ask you this. It's just, it'd be a good encompassing question. What we're going to see is, and we're going to do this in Unit 4, is you can come up with the equation, right? There's nothing wrong with that. You know something about the vertex, which we haven't done yet. But if I write this as a equals x minus h squared plus k, the vertex, which we'll learn today, is going to be h and k. So h is going to equal 2, k is equal to 3. You don't know the a value, but what do you know? It goes through some points there somewhere. It goes through, you could pick the y-intercept, where x is equal to 0 and y is equal to -5. You want to find the a value. This is a question you guys already know how to do. You just plug it all into here. It will spit out an a value, right? After you do that, you could expand it and write it like this. Then you could do quadratic equation. To tell me once you have those roots, I'll leave that up there for a sec. Okay, we're going to do this, so don't stress. Like, I'm going to do questions with you that actually do this. Okay? But it's, you already know how to do it, basically. It's just a different form. Once you have the x-intercepts, there's just more points. Right? You could go back and fill in the table to prove that it was actually quadratic. Not a nice question. Would I ask you to do that on a test? It might be a one-question test because it's pretty encompassing. One question with 30 marks. Go. Wouldn't be nice. I wouldn't be nice by doing that, right? But can everybody kind of see that it's all tied together, right? And that kind of gets back to the quadratic flow chart that I gave you. All I've done there is written the quadratic in vertex form and then switched it to standard, right? Using expansion. So if I pull that up, it's a good point of thought. If I look at this, all I did is I gave you an equation. Let's get rid of this stuff. Right? I gave you an equation in vertex form. I used expansion, the outside, right, to switch it to standard form. And then I used the quadratic equation to switch it to factored form so that I could read off the roots. That's all I said I was doing with that other question. Just bouncing around on the flow chart. Okay? I'll give you some questions. It won't be like that one, hopefully. Okay?